Hey guys, Turnbull here with your video of the week this week. Like I said in the announcement, this week we will have one video posted on Wednesday, and then next week we will have another video posted on the Wednesday. So your assignment for the week, which will be posted on Thursday this week and Friday next week, will only deal with one new concept. So today we are learning about the sine ratio. Last week we talked about tangent. Now we're going to talk about the sine ratio. Before you get started with this video, you should take a look at the activity that's on page 9. It's much like the activity that you did for tangent, just taking a look at these ratios without actually talking about the same kind of math that we're going to do here. So remember from last video, we talked about SOH. We talked about tangent last week. So TOA was tangent. And this was tan theta equals opposite over adjacent. This week, we're dealing with sine. And sine is so. Sine theta equals opposite over hypotenuse. You see this pattern? You've got 1, 2, 3, 1, 2, 3. Okay, sine theta equals opposite over hypotenuse. Okay, now you can probably imagine that when we talk about cosine next week, it's going to be cosine theta equals the adjacent over the hypotenuse. All right, let's take a look at some examples here. So this first one asks us to write the trigonometric ratio for sine n and for sine q. So let's start with sine n. It's opposite over hypotenuse. This is going to be the hypotenuse. It's the one that's across from the right angle. So this doesn't change. For n, the opposite side is 5. It's opposite of this angle. So it's going to be 5 over the hypotenuse, which is 13. For sine q, now we're talking about this angle here. The hypotenuse is still the same, but what changes is that the opposite side is over on this side. So now it's 12 divided by 13. Okay, now it wants us to write these as decimals to 4 decimal places. So 5 divided by 13 is 0.3846. And 12 divided by 13 is 0.9231. Okay, very simple. Example 2 asks us to calculate the following ratios for the given reference angle. So it wants the decimal here. What is the sine of 64 degrees? 64 degrees. The sine, and we can do it to 4 decimal places just like last time, is going to be 0.8988. Okay. If your calculator has a fraction button, you'll be able to turn that into a fraction. And now we'll move on to using the ratio to solve for a side. Okay. Last week we talked about solving for sides using tangent. This week we're going to talk about solving a side using the sine ratio. So we have 53 degrees here. Remember that theta is always the angle. So sine of 53 degrees, that is really messy. Let's try it again. Sine of 53 equals, the opposite side is this x over the hypotenuse, which is 22. Now when x is on the top here, we're going to multiply these two together. Why do we do that? Because these are connected by division, and in order to get it across to the other side, so x is by itself, we have to multiply it. So we're going to take the sine of 53. Let's just write that down. So we're going to do sine 53 times 22 is going to equal x. So 53, the sine of that, and we're going to times that by 22. Enter. And that gives us 17.57. So x equals 17.57. What are our units? Centimeters. Okay, so when the x is on the top, you multiply them. Now let's take a look at an example where the x is going to end up on the bottom because we've got sine of 40 degrees. Opposite over hypotenuse. Opposite is 15. This time we don't know what the hypotenuse is. Okay, now if you remember what we had to do last time, we multiply the x over to the other side and then divide by sine 40. So what we get is x equals 15 divided by the sine of 40. So let's put that into our calculators. 40. No, I don't want the second function. So that's our answer there. And then 15 divided by that answer gives us x equals 23.34. And we're in centimeters again. Okay, with all of these ratios, the math is the same. The question is just which sides do we need to put where? Okay, so you got to remember those ratios. So, OA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Okay, it's the same pattern each time. If you can memorize these patterns, these questions will be very easy for you. Okay, last example. A ramp has an angle of elevation of 20 degrees. Let's draw ourselves a triangle here because we're going to need one. So it has an angle of elevation, which means it's the angle between the ramp and the floor, of 20 degrees. It has a vertical height of 1.8 meters. Vertical is up and down. It wants to know what is the length of the ramp. Okay, that is not this one, that's this. So here we're solving for the hypotenuse. So sine theta equals opposite over hypotenuse. Okay, so sine of 22 equals 1.8 divided by x. X is on the bottom. So now we're going to have to swap these two places. So x equals 1.8 divided by the sine of 22. And that gives us 4.81 meters. And it's a word problem, so we need to give it a word answer. So the ramp is 4.81 meters. Okay. Very similar to what we did last week. Should not be too much more difficult. If you felt like you understood the stuff from last week, this should not be more challenging. And next week will be more of the same, just using a different ratio. All right, so be prepared for that. If you do have any questions, please make sure you either book a time to talk to myself, Miss Thomas, or whoever your teacher is, or send an email. Don't suffer alone. Make sure you get help if you need it. All right, I will talk to you guys next week.